Hi, I'm Craig Smith, a former New York Times correspondent and host of the podcast Eye on AI. I'm also a special government employee at the National Security Commission on Artificial Intelligence. And in this role, I'm serving as the host for NSCAI's podcast series on the Commission's work. This is the 5th episode of 6, looking at the Commission's first quarter recommendations to Congress. In the 2019 National Defense Authorization Act, the Congress established the National Security Commission on AI to consider the methods and means necessary to integrate artificial intelligence into the national security and defense needs of the United States. The commission consists of 15 commissioners selected primarily by Congress and is led by former Google Chief Executive Eric Schmidt and former Deputy Defense Secretary Bob Work. Last month, the Commission issued its first recommendations to Congress covering 7 lines of effort, 6 of which are public and 1 of which is classified. We spoke with the commissioners leading the unclassified groups about their recommendations. In this week's episode, I spoke with Gilman Louie about efforts to maintain U.S. leadership in AI hardware and 5G. He spoke about the need for a national microelectronic strategy and policies that would advance spectrum sharing for 5G to create a global alternative to the Chinese telecommunications giant Huawei. I hope you find the conversation as important as I did. Gilman, if you could introduce yourself to listeners. Certainly a lot of people know who you are, not everyone does, and how you got into machine learning and how you got to the commission.
Sure. So my name is Gilman Louie. I am a partner in a venture capital fund located in San Francisco called Ossip Louie Partners. Prior to that, I was the first CEO of In-Q-Tel. In-Q-Tel is a nonprofit established to find new technologies for the national security mission. And before that, I was in the video game industry for 25 years, where I first cut my teeth on writing algorithms to mimic human-like behaviors in things like video games, simulations, and those kinds of applications.
And where did you go to school?
I went to school at San Francisco State. I'm a product, proudly, of public education. I went K through 12 in San Francisco and then attended San Francisco State University.
And then how did you get to the commission?
I was doing a lot of work for the Defense Department as a special government employee. I worked on issues ranging from things like software to 5G. I was asked if I would be interested in working as a commissioner. I was appointed by the Commerce Department. I think because of my venture capital background, my understanding of national security and the direct application of AI and ML on the national security mission.
The first quarter recommendations have been submitted to Congress. Can you talk about the need for a national microelectronic strategy, which was the line of inquiry that you were heading?
Yes. So on the microelectronics side, we felt very strongly that for us as a nation to lead in machine learning and artificial intelligence, that we needed to lead not just from a software point of view, but also from the actual electronics. And the electronics are really, really important because one of the key requisites of artificial intelligence, particularly in areas like national security, is that you want the compute to be as close to the sensor as possible. And the only way to do that is embody certain parts of your capability in the actual microelectronics itself. Our view was that you couldn't just rely on general purpose processing or GPUs, if you wanted to have high speed breakthrough kinds of capabilities that we were looking at.
Yeah. In reading the recommendations, I didn't realize how dependent the U.S. has become on foreign suppliers because Intel, NVIDIA, these big chip makers for AI applications are all American.
While the U.S. continues to lead in things like innovation, design, and engineering, the actual supply chain of manufacturing those chips, the labor, the know-how of operating those fabs, the ability to take advantage of low-cost capital clearly moved our ability to be self-sufficient in microelectronics to overseas. Countries like Taiwan with TSMC, the Chinese are moving very, very quickly, not only in the operation of these fabs, but the actual know-how and how to actually, from an operations management point of view, operate these locations. And so as the U.S. became more and more specialized in what it does best, design and engineering, we kind of moved the quote-unquote lower-cost manufacturing profit areas offshore. And that created this supply chain dependency that we're currently in. And for all of us who are kind of wrestling with the coronavirus, we understand the challenges of being dependent on foreign suppliers.
So how would a national laboratory and incubator focused on microelectronics R&D fit into the strategy?
Access to the actual production of the technology is critical for startups. And to have access to next generation fabrication capabilities like 7 nanometers is beyond the scope of most companies. Now, the Chinese are becoming the largest consumer of these electronics, mainly through their consumer electronics industry. And from a consumption point of view, a large portion of the buying now is being taken place overseas. So capital, which used to be supplied through American venture capital funds or private equity funds, increasingly for microelectronics is becoming unavailable. You can get capital, but usually that capital involves foreign direct investors or through indirect investors. And that, again, creates additional stress into the system. So we think the incubator will open up access to more capability and uses of this technology and design platforms, as well as hopefully creating an environment where U.S. suppliers of capital can have confidence that they should invest in these kinds of startups.
Again, on the lab and incubator, is that for established companies to come together and pool ideas and resources, or is that to encourage a hardware startup ecosystem focused on high-end microelectronics?
I think we really want to do both. From our prior experiences, when you bring in startups and existing larger companies to work problems together, you yield some pretty interesting results. This is more than simply, let's have some incubators for a few startups to get together. Our greater hope is, in some cases, where it's appropriate, some of these larger companies can become sources of capital as well for some of these startups. So I wouldn't exclusively lock out large companies. I think there's a lot of research areas in which we can cooperatively work between small companies, mid-sized companies, as well as established companies to go off and discover new solutions to these new problems.
Yeah, and that laboratory and incubator, is that a physical locale or is that virtual?
We haven't decided at this particular point. There's lots of ways to do it. You could do parts of it virtually. You might want to have a network of regional incubators, again, to simulate the broader base. I think that's part of an implementation strategy that if we got the green light to do, that we would go off and study and make a recommendation on.
The concern is that the government lacks trusted access to state-of-the-art microelectronics manufacturing. Has the advent of deep learning led to a sudden need for such trusted access, or does this reflect a strategic change in direction from the supply chain globalization that's developed over the past 30 years?
Well, we used to have a trusted manufacturing base. It was expensive to maintain. Running a trusted foundry is not cheap. The other challenge is trying to keep up with the progression of innovation that's happening in the semiconductor market is also difficult. And so the decision was to move away from the quote unquote trusted foundry approach and try to come up with alternative methods. And one of the methods that we came up with, IARPA did the original research on, which is their Trusted Integrated Chips program, which had this idea of a split manufacturing where you can domestically in a trusted facility or with a trusted partner manufacture the trusted parts of the microelectronics that you can stack on top of existing commercial-based silicon and create this kind of split manufacturing capability to create trust. But I think the issue around machine learning that makes this even more challenging is that, once again, if lots of your capability is embedded in the actual circuitry, not just in the software to get the kind of performance advantages that you want, you need to have a way of making sure that portion of the microelectronics is protected potentially from adversaries or players who are either trying to use it for nation state advantage or trying to steal IP.
And that is a component within the chip that you're talking about that has to be secure, or you're talking about the entire manufacturing process?
It's a component. If you think about it, if you have a part of your processors using commercial off-the-shelf electronics or circuitry, you can still use that and manufacture that overseas. Those pieces of circuitry that you want to be proprietary and protected, or to make sure that the commercially available circuits are performing as they're advertised to. You manufacture that separately, and we do a process called stacking, where we stack those layers in a way that's secure and trusted for a fraction of the cost of running a completely secure fab.
And how much would it cost to build a security-based split manufacturing facility to produce these chips for classified uses?
One of the things in our recommendation is to do what we call a site survey. Part of getting the actual cost is to do the survey itself, and that's what we're trying to get after. We would be working with a commercial partner as a part of that site survey. That cost should be a fraction of the whole cost. Now, the exact size of that, we won't know until after the survey is done. But our goal is to be an order of magnitude lower cost than running our own fab or creating our own trusted fab.
Certainly the cost of the site survey is a fraction, but do you mean the cost of building?
Yeah, the actual cost of the facility would be a fraction of the cost of building a complete facility on your own.
Right.
You get to share your commercial capabilities with your commercial partners, and you only are building that special component section and adding on to that capability.
And so it wouldn't be a complete foundry. And in the report, I think you said to build a complete foundry would be something on the order of 20 billion. Was that right?
Yeah, that's the current estimates, the kind of industry guesstimate of what a next generation foundry would cost. If you were looking at today's foundries, like TSMC's foundries, typically costing $7 to $10 billion. And we think that if you're going to go to the next generation of scale, sub 9 nanometer, sub some nanometer facilities, you could easily spend $20 billion just to do a complete stand-up of a fabrication facility.
So the split manufacturing idea would be a fraction of that cost.
Correct.
And certainly it's early to answer this next question, how it'd be financed, but just generally, would the government make a certain investment and maybe a guarantee product acquisition out of the foundry, and then the private company would finance the rest of the facility?
I think you're right. I think it is early to call. And there's multiple ways you could do it. One, as you pointed out, is we'll buy a certain line, we guarantee the use of that certain line to buy chips. So that's one way to do it. The second way is you could share some of the costs of setting up the split fab itself up front from a capital point of view and put that into it, and then buy chips as you need it. Third is you might find other partners out there who also need split fab capabilities, and you can share that cost with other users. And that could be other companies, other nation states that have similar sorts of problems to the US. All of this is speculation right now because, as you pointed out, we're still in the let's see how much it's going to cost us camp before we actually go down to the business model.
I understand the globalization trend and the move of manufacturing to China and places like China. Even Taiwan is now very heavily dependent on China. It's moved a lot of its manufacturing to China. But why has funding for microelectronic research been declining? I mean, I understand the implementation and why people have sought cheaper manufacturing markets. But why has there been this decline in research funding?
I think some of it was Moore's Law. There was a moment in time where people felt that more funding needed to go to things like software and algorithms than in hardware. And hardware was going to just naturally get smaller, cheaper, faster as we were climbing that Moore's Law ladder. And it wasn't that we zeroed out research, but we kind of kept it flat while industry zoomed off ahead. Our actual expenditure as a percentage of GDP in 2018 is the same as it was back in 1978. And $6 billion seems like a lot of money, but as we just pointed out, $6 billion doesn't even buy you a fab. So that's problem number one. As we're running to the end of Moore's Law, as we know it, at least with silicon, as we need to come up with other strategies, new materials, new designs, new architectures. And as the importance, as I was saying earlier, of critical technologies like AI will have on the dependencies around microelectronics and architecture to fully utilize the capability of machine intelligence, then we were calling, and I believe rightfully so, not just an increase, but a relook and a priority of thinking through our entire nation state's strategy. And that's why we said, hey, it's more than just adding money. The United States really needs to have a microelectronics strategy that we can move out on.
A lot of the recommendations, a lot of your section of the recommendations talks about Huawei, and the UK just announced that it's going to be working with Huawei in some capacity in 5G. There's been a lot of pressure brought to bear on allies not to work with Huawei. In particular, a group of senators, including Marco Rubio, wrote to the UK government urging them not to work with Huawei. In that letter, they said the facts are clear. And this is something that's bothered me in following the story. I think it's bothered everybody. In fact, the facts are not clear to the public. There's been a lot of confusing noise, a lot of bold statements, but no public facts. And the U.S. claims Huawei has the capability to secretly access networks through an undisclosed backdoor in its hardware. In the same vein, Bloomberg published a widely disputed story a year ago that Chinese chip manufacturer Supermicro had embedded tiny spy chips in its motherboards. Without clear facts, skeptics see this all as a misinformation campaign to give the U.S. time to catch up on 5G and quash Chinese competition. For the benefit of listeners, can you describe the specific threat from Huawei's involvement in 5G networks?
It's no secret. I mean, it's widely publicized Huawei's IP challenges that it's had. Suits by Cisco, Motorola, Nortel, the theft of IP from T-Mobile back in 2017 shows a pattern of behavior of lack of respect for other IP. Yet in the criminal cases out of places like Africa on corruption also shows a pattern of behavior. You may not want to trust your critical infrastructure to a company that operates on both the IP framework and corruption points of view that Huawei's had in the past. Now, Huawei claims that that's behind it and that it wants to be a better Huawei going forward. But even if you were to take Huawei at its word, being a Chinese manufacturer has challenges. They have to operate within the laws of the Chinese government, which has moved out on what we call civil military fusion requirements that says national security trumps all. Well, it's more important than the economic benefit to that country. If the country asks you to do something, you cannot refuse that ask. Put that together with the made in 2025 Chinese goal of being totally self-sufficient on Chinese hardware, sets up the condition not for one of trust. So whether or not you believe the assertions of actual backdoors, you put that framework on. And I'll add one other challenge that Huawei has had in the past is, let's just call it poorly written software that has a lot of vulnerabilities in the software, either by design or by accident. Nevertheless, if all of our information traffic, as well as our allies, as well as our personal information, our personally identifiable information, are flowing through their equipment, and their equipment is a foundation of your internet traffic, that's an uncomfortable position for any nation state to be dependent upon. And it's not just military. It's our businesses, our global businesses. So even if you were to ban Huawei out of the US, that doesn't protect you because your operation profile as a country extends all the way across the globe. So that's its own set of problems. And in 5G, I compliment Huawei's technology and architectures. They do a great job in building out their technologies around 5G, and they moved out very quickly on what we would call mid-band sub-6 gigahertz spectrum equipment. The United States telecommunications industry has begun moving out on millimeter wave technologies. But turns out that sub-6 has a lot of advantages over millimeter. Millimeter is very great for high speed if you're really, really close. But if you want to service an entire country, you really need to do it in a way that has range and has bandwidth. And the Chinese are moving out very swiftly on that mid-band. The challenges for many of our allies and for the US is alternative suppliers. Yes, there's Nokia and there are other equipment manufacturers out there, but they just can't get the volumes of orders. A domestic supplier of technology to China has natural advantages over other countries.
Eric Schmidt, in a conversation I had with him last autumn, said that there are ways to build trusted systems from untrusted components. So presumably the vulnerabilities of Huawei's components could be mitigated. And what you're saying is that Huawei's dominating right now because they're the only game in town, or they're the most economical game in town. So it's a matter of coming up with an alternative. It feels like all of this noise about how untrustworthy Huawei is a way to give everybody pause while the U.S. scrambles to come up with an alternative. Is that too cynical a point of view?
Yeah, I think it's a little bit cynical. It isn't a question of the U.S. coming up with an alternative. One of the reasons why Burr and Warner is pushing their bipartisan utilization strategic ally telecommunications act is they would like to see an open access radio network architecture. If you had an open architecture, and Huawei, as well as all the other companies, made available their components so you can disassemble and reassemble it in a way that you can create these networks with trust. I think that would be a leveling of a playing field that says that, okay, Huawei, as well as other manufacturers, not just Huawei, this is just a better way to have transparency in building your radio networks. And ORANs have a huge opportunity globally, not just here in the US, as a global standard, right? The difference between 5G and 4G LTE and the prior generations before is 5G architectures are really the first architecture that truly gives you the bandwidth to go completely wireless, which is really important for artificial intelligence because that wireless infrastructure is the transport between where I sense, where I compute, where I share, and where I decide. And if that fabric is untrustworthy, then you're going to have a major collapse in your trust of the actual AI algorithms themselves. It's like a virus that you get out of the 5G network suddenly spreads to your confidence of what the machines or what the algorithms are telling another machine to do. So this is really important to get right. Huawei is a challenge in and of itself, as I said, because of its past behaviors and practices, and because of the requirements of the Chinese government around its suppliers of electronics. But also because Go Open is a better architecture. If Huawei wants to go open, that would be the benefit to Huawei as well as to every other operator in the world on 5G network.
That's interesting. Do you think it's likely that Huawei or the Chinese government would agree to open access radio networks?
Well, I can't speak for Huawei, right? Huawei has made statements that it is willing to consider ways to make their networks more trustworthy and even in selling components. But it's one thing to say, it's another thing to do it. If they were serious about it, they should be much more aggressive and communicating directly to other companies and to other countries that they are willing to sign on to a consortium of other companies adopting O-RAN architectures and that they would support it. If they did that, that would be not a final step, but that would be a good first step on restoring trust around Huawei.
Is there a danger of the U.S. decoupling from China? This talk of pressuring allies to hold off on using Huawei and their networks and using U.S. or Western allied solutions. It sounds like preparations for war. You know, countries pull apart and they organize in ways that they're not dependent on one another. Isn't codependence a better strategy? This codependence of the global supply chain, for example, as much trouble as it's caused with the coronavirus, countries are dependent on one another.
It doesn't serve anybody to be completely cut off from the rest of the world, right? I mean, that's economically not feasible. A global productivity point of view and moving quality of life globally forward, also not appropriate. Being dependent on your own domestic capability on critical supplies and having capacity to do so is also a good strategy. They're not mutually exclusive. In some ways, you need to pick and choose where you want to have your investments in terms of being able to be self-sufficient versus where you can have a broader distribution of global suppliers. And one of the things that we've learned about the coronavirus isn't that globalization is bad. It was globalization is challenging if everybody's dependent on a sole country for all of their critical components within the supply chain. So that's issue number one. Issue number two is it is a false goal to say, hey, let's go off and isolate a country from the rest of the world. No economic view would support that kind of strategy, particularly against a country like China. The flip side of that is if you're going to supply critical components into the global infrastructure, you need to be transparent. And the reason why the world has openly embraced open architectures and open software standards and open designs and around this whole idea of openness is it is a foundational element to build trust from. And what we're saying is, China, if you have a challenge because of your regulatory environments, how you have to deal with your own internal security challenges, yet you want to supply the rest of the world, you should go down a much more open and much more transparent strategy than you currently are doing right now, as exhibited by one of your leading suppliers, Huawei.
Is it possible that Chinese don't play ball and the world divides in much the way that it did during the non-aligned movement? I remember Ericsson sold the non-aligned movement because the U.S. wouldn't sell to them. So there were two standards developed, two manufacturing ecosystems, and they kind of existed side by side.
We could go down that world, right? Some nation states have created an alternative to the internet, their own trusted internet for certain kinds of uses. China has one of those for its military communications. I don't think that's a attractive strategy. I think China, in order for it to continue to grow as a nation and be productive and to be a valuable partner to the rest of the world, as I said earlier, should go down the path of being much more transparent and much more open. If they head down that path, it will be good for the Chinese, it'll be good for Chinese industries, and it'll be good for the rest of the world. You layer that together with a reframing of what respecting other people's IP should look like, and you hold your companies accountable as a nation state to play by those standards. I think that's a good China. And China clearly has the capacity as they move from a kind of a regional nation state into a global supplier of many kinds of technology. They're going to need to make those kinds of adjustments. This is not about Chinese advantage or American advantage. This is about trust. And if you're going to be selling infrastructure, if you're going to be selling critical components, particularly in an environment where so much of our information is moving through, that's the way you have to operate.
You talked a little bit there about the need for open access radio networks and different areas of the radio band. Again, for listeners that aren't that familiar with these issues, can you explain the mid-band strategy and how the open access radio networks fit into that and the limited bandwidth available in the U.S.?
Sure. 5G or fifth generation wireless promises two things. It promises much greater speed, the ability to put more data more quickly down to your devices, as well as your devices to communicate back up. And the hope is also to have widely available networks. So it's great to have high bandwidth, but if you can't depend on every time you turn on your phone or your device to actually find a network, it's not particularly useful. So you got to do both. The U.S. companies, for lots of reasons, decided to move out on millimeter wavelength. Now, millimeter wavelength is very, very high speeds. The challenge with millimeter wavelength is it only goes short ranges. And so without a huge amount of infrastructure investment, order of 8 times to 13 times the kind of investment we as a nation invested in 4G, we cannot build out that millimeter wavelength 5G architecture to service 85-90% of the US populations, much less go off and touch the rural areas, right? It's too expensive. It's great for places like New York and Los Angeles and Chicago, but not so good in rural areas for the rest of the country. The other band is what we call mid-band, which is still fast, not as fast as millimeter, but megabit kind of speeds. But it goes over much longer ranges than millimeter, right? So you can have ubiquitous coverage to all your major metropolitan as well as population areas and cover most of the U.S. Now, our challenge is in order to operate in that sub-6 band, which is the ideal band, what we call the Goldilocks band, because it's high speed as well as good range and beams that can travel through buildings and through trees and shrubberies that sometimes millimeter has problems with. That Goldilocks band is also the same band in which military systems and satellite systems operate. Radar occupies those bands, and the U.S. Department of Defense reserves those bands for military operations and military use because radars need high discrimination at good range, and they operate in these bands. Now, the Chinese have moved out, and the rest of the world is moving out on this mid-band. They don't have the same sort of conflicts that we have with our Department of Defense. So one of the things that we're advocating in our report is that we share those bands with the military to make it available for enterprise and consumer use and use a sharing spectrum strategy. And if we were able to do that, we can then provide the Goldilocks bands to U.S. industry as well as U.S. consumers.
And internationally as well.
Correct. We had to share in those places anyway. If a ship goes overseas, it can't turn on its radars and knock off everybody else's 5G networks. So we're going to have to adopt those protocols one way or the other. We recommend that we should do the same here in the US because we're going to have to do it anyway overseas.
Why would China not have faced the same problem? Or is it just that the U.S. national security infrastructure is so much larger than other countries?
The U.S. has one of the most advanced radar systems in the world. We have the best national defense and military systems in the world, which means we've been operating in those bands a lot longer than anybody else has. And we have unique capabilities that other countries would dream of having. Nevertheless, they occupy exactly the same parts of the spectrum that a mid-band 5G wants to operate in.
So to develop this mid-band in the U.S., it's really a political consideration more than a technical one.
Well, it's more than just a political one, right? I mean, there's two strategies. One is to vacate. In other words, you say, okay, we want to start using this spectrum for commercial and consumer use. The military should move somewhere else. That is doable, but very expensive, and it's going to take a long time. You have to go through all of your military systems, find out which ones are in conflict. Then you got to find some other part of the spectrum to operate in, which is difficult because the reason why they operate these spectrums is because that's the best place to operate in. And it's going to take a lot of money then to rebuild those systems, to retest those systems, to get them up. And it's going to take a long time because you can't start using those areas of spectrum until you vacate. So one of the things we think that would be a more appropriate strategy, and that something that we can move very quickly out on, is going down the sharing model to be able to share those spectrums when the military radars and satellites are not in your particular area operating. You can go off and use that midband. If not, you get either bumped up to millimeter or bumped down to 4G LTE, just like the way your phone does now anyway. So we think that's a more appropriate, more quickly move out strategy and presents the lowest risk of us having a problem on our military side while giving us the best performance on the consumer side.
Are we talking about two different things, the mid-band and then the microelectronics research and development strategy, or is there a big overlap there?
Well, they're codependent, right? I mean, we need faster chips so we can process what we call processing on the edge. So we can make devices really smart, still be energy efficient, to be able to have certain kinds of decision making at the very edge of the network. But we also need the ability to transport that information. If you just had a smarter edge, but no ability to move that information at the speeds in which you need to make decisions with across the network, it will have limited value. The flip side of that is if you can have a highly efficient and effective network, but you can't compute very well at the edge without using up all your batteries, your machine intelligence infrastructure also collapses. So you actually need both in order to have the world-class, state-of-the-art framework to build next-generation machine intelligence around.
The recommendations include establishing a senior leadership panel within 30 days and then provide an interim briefing to Congress after 90 days. That's a pretty accelerated timetable. Do you consider this critical because of the challenge of Huawei as countries adopt 5G?
First of all, it's critical for the U.S. to have a strategy and to move out quickly on that strategy, not just for our own competitiveness, but to provide the world with an alternative architecture and an alternative framework to think about how to operate, particularly in these mid-band areas. Without that, where every country right now is faced with, great, you're telling me I shouldn't use Huawei, can't afford to go to millimeter, and the other alternative suppliers don't have the performance at the cost that I need. So they're locked. They have no alternatives, right? The UK has said, well, okay, our strategy is we're just going to use Huawei equipment out there on the edges of the network and not really for anything that's important. But, that's a pretty unsatisfying strategy if you can't trust the company that's providing you that infrastructure, even if you try to push it out to the edge, because you're still attaching it to the network. So our hope is to move quickly on this, to get to a strategy to quickly implement a mid-band 5G architecture and to provide that architecture and capability to any other country who are similarly challenged as the U.S. is challenged and still wants to give great capability to its nation.
Is there some message that you would like people to hear?
One of the things that people are missing is that as capable as machine intelligence, AI, deep learning, and the various approaches, AI is still in its early days. We're decades off from a general intelligence capability. And so we have to do a lot of heavy lifting, and it requires a lot of researchers and a lot of investment. And if the U.S. really wants to continue its lead, and make no mistake, the U.S. is in the lead in many areas of artificial intelligence, then it needs to invest, and it needs to do so with a strategy behind itself. You have a competitor nation like China who's equally motivated, who really sees this as a foundational piece of technology necessary to be successful in the next industrial revolution. It, as a country, has committed to not only be competitive in the 2025 to 2030 timeframe, but to be superior to all other nation states in technology related to AI by 2035. They have a whole of nation approach. Their companies are all focused on being the best. And without a similar focus, doing it the way Americans would do it, not necessarily the way the Chinese would do it. But unless we have that same level of commitment, we will not win. And the challenge with that is not just simply an economic one of economic advantage or even military advantage. It would be a terrible thing to have an adversary who has better intelligence than you do. But with that machine intelligence, with that AI, is encoded your ethical considerations in your framework. And I believe that the U.S. framework, ethical considerations of privacy, personal protections, ethical uses of AI is the one that should lead the world. That's going to be really important. And so this is a battle and a competition that we cannot afford to lose.
That's it for this week's podcast. I want to thank Gilman for his time. If you want to learn more about the National Security Commission on AI, visit their website at nscai.gov. If you want to share your views on AI and national security, reach out to NSCAI at inquiry@nscai.gov. The country needs you. And remember, the singularity may not be near, but AI is about to change your world, so pay attention.